And last step is replace u, right? Replace u with what it is and clean it up a little bit, right? That can be simplified. That's negative 1/2. This is u to the negative 8 plus c. But u was, Nicholas had picked the whole bottom, right? Yeah. As our... That's it. If we take the derivative of this, we should get this. How are y'all feeling about this? See, Nicholas did good. He had no idea when he started, right? And then he tried something that didn't work, and then he tried another one, and it worked. But what you want to do is get to a point where you see it. Like you just kind of see it, and it'll become automatic. You need to do about, I don't know, maybe 3,000 problems, and then you'll start to feel pretty comfortable with it.
Only 3,000.
Yeah, that would probably still not be enough. But okay, how about we try something else? I like making them up rather than using the book, but okay, how about this one? Boy, this one's going to be a little tricky. So I'm making this one up, so I know it's going to be a little bit weird. Although it looks familiar. Oh, it's actually pretty familiar too. Okay, yeah. All right, next up to bat is James Sykes. I'm assuming you caught your breath already, yes?
Yeah.
Okay, good.
Yeah. So, what would happen if we used 1 plus cosine squared as the u?
Then you would be taking a shot at it. Would you like to do that? Okay, let's do it. All right. So u is equal to 1 plus cosine squared x. You want that whole thing, right? Not the root, though? Just that?
Just that.
Okay. So what is the derivative of that, then? So derivative of 1, go on, right? So derivative of cosine squared x. You got to use a little bit of chain rule, right? So go ahead. Do you want to?
Put that to the front so that it's 2, then that would be...
Cosine to the first power, right?
Yes.
Times chain rule,
That'd be
negative sign of x. Okay, now let's just clean that up a little bit because that's messy. Negative 2 cosine x times sine x. Okay, so remember, you're supposed to pick something u, and then you're supposed to see its derivative there, right? Here's the derivative, right? Do you see that there? Do y'all see the 2x there? That's very important. So do you remember from pre-cal this identity? That sine of 2x is equal to 2 sine x cosine x. This is one of the big ones from pre-cal. Like the Pythagorean identity is the biggest one, right? Sine squared x plus cosine squared x is 1. This double angle identity does peek its head out quite a bit in math, so it's on your formula sheets, but I think you should try and make sure this one's in here. So if you look at that, do you see we do have that? Yes. We do. This numerator is actually it's sneaky. That's why I did this problem, because it's kind of sneaky, but it's there, right? That's really 2 sine x cosine x. Do we have that? Yes, but we're off, aren't we? We have a negative here and we don't have a negative up there. That's okay, right? Because we can just like multiply both sides by -1, and that will make it what we want it to be. All right, so here we go. I'm going to rewrite this. I'm going to write du, and then it's going to become -2 cosine x times sine x dx. That's just putting the dx on both sides, or moving it to the right side. And now let's make it positive, right? So I multiply this side by -1, multiply this side by -1. Do you want to keep going, or do you want me to call on someone else? Because I'm ready to rewrite the integral, if you are. I'm ready to rewrite it if you're ready.
Yeah, I'm ready.
You ready? Okay, so you tell me what to write.
Alright, so the integral, then it is going to be, let's see, here, we pass, sorry.
So what does all of this turn into? What does all that turn into?
That will turn into -1.
-1 du, right?
Yeah.
So is it all right if I put the -1 out here?
Yeah.
And just slap the du right here?
Yep.
Okay.
Then it's going to be 1 over.
1 over,
square root
good.
of u.
1 over the square root of u. We're going to see that. Remember, this is in the denominator, right? And it's under a root, so you got to do 1 over it.
Yeah.
And then the u is that thing right there, right? And that's what we did the substitution of. This right here is that piece right there. All right, let's move on to Adam. Where's Adam at? Adam? Okay, Adam, you following along okay? All right, Adam, what would you do with that at this point?
You find that antiderivative
Okay.
u to -1/2.
Okay, good. So you're going to convert that to -1 integral u to the -1/2, and then use your power rule, right? Okay, so what would that become? I'm going to keep the -1 out here, but what would the next piece go?
So it would be the power plus 1 over 1.
So 1 over that power plus 1, right? So -1/2 plus 1, that's a half, right? And then u to the half, and then plus c. Integral sign goes away, right? Integral sign goes away because you did the antiderivative. The plus c shows up. What about that -1? Does that -1 have to distribute through to this constant? Well, the constant can be any constant, positive or negative. So it doesn't matter if you put plus c or minus c, it's still a constant. So you don't need to worry about distributing the negative through. Okay, any constant you ever have out here, you do not need to worry about attaching it to the c at all. All right, it's just a constant. So this should become -2. And that's just the square root, isn't it?
Yeah.
Square root of u. But what's u? 1 plus cosine squared x plus c. There we go. So what's it going to take for you to get good at this? Practice, right? You're going to have to practice. You're going to have to do a lot of problems.
I have a question.
Yes, go ahead.
So you just said that the -1, you don't have to distribute that to the constant.
Yes.
But what if the constant is given? Then you have to
Yes.
distribute it?
If we knew what this constant was, then that -1 would matter.
Okay.
All right? But it doesn't here. And if you're finding antiderivatives, right? If you're finding antiderivatives, then you're always going to have plus c, because it's always going to be a family. So that's never really going to happen.
Okay.
Yeah. Okay, you ready for the next one? All right, good. Here it comes. Okay. Yeah, okay, we'll just baby steps. right? Shit. Sorry. Take the cube root out of there. I forgot what I was doing. We would not be okay with that one. Hogan,
Yes, sir.
right? Can I ask you a question, Hogan?
Yes, sir.
So you fly, right?
Yes, sir.
So do you have any opinions about the helicopter crash?
It was, I don't know, I haven't read the NTSB report.
Yeah.
But usually how these things go, it's down to pilot error.
Yeah.
This guy took off in a helicopter, which helicopters usually don't go over 500 feet.
500?
They don't go over 500 feet AGL.
Okay.
So, and also it was IFR conditions, which means visibility below 3 statute miles. Clearance below 500 feet around a cloud. So that's already a bad deal to fly helicopters in IFR. You need at least 2 pilots. I don't know if they had 2 pilots.
Yeah. IFR is instrument?
Flight rules.
Yeah.
And from this pilot taking off like that, I don't know, because that type of helicopter is I think a $10 million helicopter equipped with the latest avionics systems.
Yeah.
ASB, GPS, all that stuff, and also synthetic vision.
Mm-hmm.
So he could have survived, so that must mean that the conditions, and wind conditions were higher than it should have. Because NTSB report on the news says less than ideal conditions. So what I think, sadly, is that Kobe Bryant says, no, we need to go, we need to go. And the guy says, no, we don't go. And he says, well, you're gonna lose your job if we don't go. He goes, all right. It's always the pilot in command's responsibility to always say, no, we're not
Yeah.
going. Find a different pilot. Here's a pilot shortage right now. You can get a job anywhere.
Yeah.
At least that's my opinion.
That's a good opinion.
But on this, I'm clueless.
Well,
Like, would you use X to 6?
okay, so you want to go with X to the 6?
Yeah, but it's just, I don't know what you do because X squared would be different.
Okay. But you gotta take a swing, right?
Yeah.
Fortunately here, the consequences are
Yeah.
you know,
It's not like
okay,
that.
that's right. So, okay, so let's go with this. All right, so what's the derivative of this?
6x to the fifth.
Yeah, so 6x to the 5th, and there's a little bit of a problem with that because we don't see that there, right? Right, so that automatically you're starting to think maybe that's not good. Let me just suggest one more thing maybe. Would this have changed anything had we grabbed that and that? It still would have had the same thing here, right? So, James, you got something?
Can we rewrite one, so the one, so leave the 1 plus the same, can we rewrite that as X?
Oh, leave the plus 1?
No,
Oh.
saying, can we rewrite it as X? So 1 plus X to the 6th, can you rewrite that as 1 plus X to the 3rd squared?
Rewrite this x to the 6th as 1 plus x what?
X to the 3rd squared?
X to the 3rd squared, like that? Yeah, I mean, algebraically, do y'all agree? I mean, that would be legitimate. So let's see if that helps Hogan at all. Now that, I admit, is not a natural move. And James, I showed you that last semester. So that's a little bit, that's not natural, is it? But do you see that, Hogan, now?
Yes, sir.
Okay. Y'all agree that that would be, I mean, it's right to do that, right? But why, what do you gain from that? What can you use as your u instead, Hogan? Instead of the x to the 6th.
X cubed then?
Yeah, why don't we try the x cubed, right? So if you do that, then here you're going to have 3x squared, which you are off by a constant, right? But big picture wise, if this x squared stuff is part of the du, and this is going to turn into, on the bottom, 1 plus what? U squared. So can you imagine what that looks like? It's like something 1 plus u squared.
Yes, sir.
And does that look familiar?
Oh, yeah.
That's the special one, right?
It's the arctan.
Okay, so the more of this you can see ahead, the better. Because that kind of gives you some indication. Now this step, again, that James suggested is a trick. It's a now you see it, now you know we can play it that way. All right? So this works out. Let's continue it. Let's finish it out. And I'm glad you remembered that, James. Okay, because now we're going to do this. My dad is retired FAA, crash investigator. Then he went to safety inspector, and so he thinks it's what do they call it? CFIT, controlled flight into terrain.
Yeah.
That's the terminology they used for it.
Yeah.
But yeah, we had a big discussion about the debris field and the shape, the cone shape, and yeah. Oh, okay, sorry. Keep it here. All right, so we've changed the game. We've switched up the expression to look this way because we think it might work. X cubed, here's a derivative, dx on both sides. Now we've got to make this match, right? So y'all tell me by a show of hands, how many of you prefer it when I rewrite it this way? Like this step of peeling that 5x squared dx off to the side, does that help you all, or am I okay to just stick with this, or does that help to show that step? Doesn't hurt? You're okay with that? Yeah? So you'll see what we're doing. We're eventually going to get to 1 over 1 plus u squared, and then here's our du kind of. We need to fix it. So Hogan, you want to try and fix that? We need it to be 5x squared dx, and what we have right now is this. So how can you make this that? Do it in steps.
We'll flip both sides.
Get rid of the 3 first. How could you get rid of the 3?
Multiply both sides by 5 over 3.
5 over 3. You did the whole thing at one time. Okay, here we go. 5/3 here, 5/3 here, right? 3's cancel. And so what you're left with here is 5x squared dx. And on this side, you have 5/3 du, right? And now you've made it match, right? Everyone see how that's going to match? This right here is going to match up with this. So we'll be able to replace that with 5/3 du. Now we can rewrite the problem. Go ahead, Hogan. I'll let you finish this off. So what does this become?
1 over 1 plus u squared.
Okay, and then times, what does this become?
Would that be 5 over 3 du?
Yep, 5 over 3 du. And I'm going to pull the 5/3 out. You're almost there.
Do we just put u back in?
What's u?
X cubed?
Not yet. We need the antiderivative.
Oh.
Right? We haven't actually taken the antiderivative yet.
So would that be arctan?
Arctan. So now at this point, the integral sign is going to go away. The 5/3 is going to be here. Antiderivative of that is arctan of u, right? Of u. And then plus your constant. And last step is to replace u with x cubed. And we're done. What do you got, James?
Just a question on, so what if you just did the 1/3 first and not include the
1/3
5?
first. Do the 1/3 first.
You just have to look at it and multiply by 5?
Yeah, you mean to get the 5 to match?
If you pull the 5 first, you just do the 1/3 first?
1/3 first, then multiply by 5, yep.
Okay.
Yeah, and you could actually, if you didn't like the 5, in this particular problem, you could have pulled the 5 out in the very beginning, like that. And then you would have been working with x squared, and then you would have just done a 1/3 on both sides. But then it would have joined up with the 5 anyway, and you would have wound up with 5/3 at the end.
I'm just saying the different,
Yeah.
different steps that
I've got 9 minutes, so I've got one more problem I want to do. And this is kind of a classic problem. Do you all already, I mean, for those of you this is your first experience with substitution, antiderivatives, do you already see how this is not like calculus in the sense that I'm not just going to give you a formula that you do? Like everything is like a procedure you attempt. And it's not always going to be, oh, just bring the power down, do this. It's not monkey see, monkey do mechanical. It's more like you go with your intuition, hope that it works, and if it doesn't, you crumble up your paper and start over, right? So that's a fundamental difference between Cal 1 and 2 already, right? Alberto.
Yes.
All right. How's it going?
Okay, until you call.
Until I called on you? All right. Well, this is a little bit of a tricky problem, but before I ask you what you want to let U be, let's just try and appreciate the fact that, like, let's say this 80 wasn't here, okay? Then we could just distribute through, right? And we would just have x squared plus 2x, right? And then we just do them one by one. It would be easy, yes? Mm-hmm. If that was x plus 2 squared even, we could like FOIL that out and then distribute an x through and then do it, right? And then if it was maybe even the third power, we'd be willing to multiply it out and then distribute the x and do them each one by one, right? But once I take it to 80th power, I think you kind of submit it, right? And you're just like, okay, I'm not willing to expand that. Okay, so now with that, Alberta, take a swing. By the way, don't ever make, when you're using U substitution, which is what we're doing right now, don't ever make the substitution U is equal to X. Don't ever do that. Because what happens is you just rewrite the entire problem by replacing all your X's with U's and you're exactly where you started with. It's got to be something more than X. Do it. Do it. X plus 2?
Yes, but it doesn't work.
It doesn't work. Okay, well, I disagree. It's going to work.
Okay, so
But it doesn't seem like it is, right? Okay, let's see why this is going to work. Okay, U is this, right? So du dx is what?
1.
Okay, is 1. Do you have a 1 there?
Well, yeah.
Yeah, I mean, there's 1 everywhere, right? So do you agree if I get the dx to the other side? 1 dx? Yes? So this doesn't look very helpful, but let's see. I can replace dx with what? That can be replaced with what? du. Okay, so that's okay. I can replace x plus 2, right, with what? U. So that'll become u to the 80th. But now I need to be able to replace x, right? That's the only thing I haven't replaced. So, Alberto, what can I replace x with? It has to involve u's. Okay, you can't leave x's mixed up with u's. Any ideas of what you could replace x with?
Oh, I see.
Look at this right here. Could you solve that for x?
Oh, yeah.
Yeah, right? You could. You could take this and solve it for x. What would x be if you solved that for x?
U minus
U minus 2. So you can replace x with u minus 2.
Yes.
Let's do it. Okay? So everywhere we see x, it's going to be replaced with u minus 2. Now let's see if we gained anything here. This integral now becomes x, which Alberto said is u minus 2, right? Times, Alberto, what's next?
So, U?
U to the what? U to the 80th power, right?
Right.
Now I do need a parentheses around this, don't I? Because it's this x times that, right?
Right.
And then what is dx?
Du.
du. Now Alberto, why is that better than what we were looking at before?
Better than what?
Better than the original problem, because like here we said we'd have to expand that, right? 80 multiply, that'd be terrible, right? What about this though? Can't you just multiply that through? Right? I mean, just algebraically, that goes through, doesn't it? And so if you just algebraically multiply that through, you get u to the 81 minus 2u to the 80th du, right? And then you could do those separately, one by one. Are you agreeing your head, just like agreeing just to be agreeable, or do you see that? Yeah? You see how making this substitution actually makes this step of the algebra possible, where here you cannot distribute this x through. Why? Order of operations, you have to expand this before you can distribute an x, right? You have to expand before that x goes through. But with this substitution, because this is a single term, a single factor raised to a power, you can distribute this through.
But u is still going to be x plus 2, isn't it?
When we, at the end, we have to do the antiderivative now,
Oh,
right? Let's do the antiderivative. So just remember u is x plus 2. So the antiderivative of u to the 81 should be 1 over 82 u to the 82 minus 2 times 1 over 81 u to the 81 plus c. So we're just using our power rule here and here. The negative 2 just came along for the ride. And the final answer will replace the u's with x plus 2. So we have 1 over 82 x plus 2 to the 82 minus 2 over 81 x plus 2 to the 81 plus c. I'm running out of time, but that's it. That's our answer. You see how that worked? And you went with something, right? And it worked, right? It just seemed like it wouldn't. So this is the moral of the story here, is sometimes it doesn't even seem like it's going to work, but you try something and it does. As you're packing up, remember 5.5, this homework is very important. I would work through as many problems as you can possibly get through. I think I assigned problems 1 through 36. I will also say that while you're doing your homework, you might see this, something like, problem. And you might see numbers here, like it might be like a 2 here and a 3 here or something. Totally ignore those. We will talk about that later. Just treat this like we were doing in class. Yes? Yeah, they're kind of like limits, and we'll see. That's going to be when we do areas. My homework solution videos, I go through it and I treat it like this. I don't do the numbers. So, yeah, that's it. Do your homework. Have a great day. Let me turn off my camera real quick. I'm going to turn this off. And get